Our first topic is the six trigonometric functions, which is the sine, cosine, tangent, cosecant, secant, and cotangent. So our problem is a right triangle has an angle where the side opposite to is 5 units long and the hypotenuse is 13 units long. So let's start by drawing the right triangle. So our hypotenuse is the longest and the opposite would be the opposite of the hypotenuse. So the missing is the adjacent. So we are going to use the Pythagorean theorem, which is a squared plus b squared. But instead of plus, we are using minus because we are finding the adjacent. But if we are going to find the hypotenuse, we are going to use the plus. So our adjacent here is 12. Now let's start by finding the sine, which is opposite over hypotenuse, which is 5 over 13. Next is cosine, adjacent over hypotenuse. Oops. 12 over 13. For tangent, opposite over adjacent, that would be 5 over 12. Cosecant is hypotenuse over opposite. It's 13 over 5. Secant is hypotenuse over adjacent, 13 over 12. And lastly, the cotangent, adjacent over opposite is 12 over 5. So we completed the 6 trigonometric functions, therefore this is our final answer, and we are going to box the final answer. Pretty easy, right? So next, let's proceed to the next topic. Next is trigonometric identities. So we have here another problem, and we need to verify the identity. So it's sine squared over 1 minus cosine is equal to 1 plus cosine x. So we need to identify first which side is more complex. So obviously, the side that is more complex is sine squared x over 1 minus cosine x. So we are going to work on this side. So let's rewrite the equation. The identity of sine squared is 1 minus cosine x. And let's not change the 1 over 1 minus cosine x on the denominator, since it's clearly shown that they are now similar. So let's not change that. And let's factor out the 1 minus cosine squared. So simply let us cancel out the same sign. And now we can verify that the both sides are now the same, are now equal. So this is the final answer. Let's proceed to the next topic. Now let's move on to the law of sines. We have here problem: a triangle has angles A is equal to 40 degrees, B is equal to 60 degrees, and side A is 10 units. So obviously, the angle that is missing is the C. So we can minus 180 minus 40 minus 60 is equal to 80. So therefore, that is our angle C. Next, we need to find the other sides, which is the B and C. Okay, let's proceed. So our solution for that would be 10 over sine 40 is equal to B over sine 60. C is C over sine 80 degrees. The total for that is, so we need to rewrite it again. 10 times sine 60 degrees over sine 40 degrees is equal to 10 times 0.866 over 0.643 it is equal to 13.47. So that is the side for B. That is the measurement of B. For C, 10 times sine 80 degrees over sine 40 degrees is equal to 10 times 0.985 over 0.643, and that is equal to 15.33. So here our sides and angles are now complete. Therefore, this is our final answer. So let us box it. Our next problem would be a triangle has sides A is equal to 7, B is equal to 9, and C is equal to 12. And we are going to find the area of the triangle by using Heron's formula. So first, I am going to show you the formula. As this is the semi-perimeter, S is equal to A plus B plus C over 2. So let's substitute it. 7 plus 9 plus 12 over 2, that is equal to 14. K is equal to square root of S, close and open parenthesis, S minus A, S minus B, and S minus C. So let's substitute it again. 14, open and close parenthesis, 14 minus 7, 14 minus 9, and 14 minus 12, and its square root. So the answer would be square root of 980, and that would be 31.30, 31.3 units. And that is our final answer. Lastly, our last problem is in a triangle, the sides are given as angle A is 60 degrees, side B is 8, and side C is equal to 10. So we are going to use the law of cosine. It states that in the law of cosine, in order to find each side, or to be specific, to find the A side, it is A squared is equal to B squared plus C squared minus 2 times, minus 2BC cosine A. So substitute that. 8 squared plus 10 squared minus 2 times 8 times 10, and cosine 60. A squared is equal to 64 plus 100 minus 160 times 0.5. Since we know that the value of cosine 60 is 0.5, you can use your calculators in order to solve this problem. A squared is equal to 164 minus 80. That would be 80 square root of 84. And since the A has square root, we need to cancel out the squared and the square root, and that's why only a will be remain, and that would be 9.17. Next, we are going to find the angle B. To get the angle B, we're going to use cosine B is equal to a squared plus c squared minus b squared. And substitute that. 9.17 squared plus 10 squared minus 8 squared. That would be and over 2 times 9.17 times 10. And using your calculator, you need to press the shift and cosine, and that will give you the cosine -1, or else it will not give you the right answer. We need to remember that in order to find the angle, we should always press shift. So here we have cosine -1, open close parenthesis, 84.089 plus 100 minus 64 over 2 times 9.17 times 10. And that would give us the answer of 49.09. So that is for the angle B. Next, cosine C is equal to a squared plus b squared minus c squared over 2 times AC. I mean 2 times AB rather. Now let's proceed. 9.17 squared plus 8 squared minus 10 squared over 2 times 9.17 times 8. And we need to press the shift again, and that would be cosine -1 times 84.089 plus 64 minus 100 over 2 times 9.17 times 8, and that would give us the answer for the C angle, 70.867, or we could round up into 70.9. To verify if this is the correct answer, we could add all of the angles to get the 180-degree answer. So let's add all of them. 60 plus 49.1 plus 70.9, and that would give us 180 degrees.